Dear students, uh, let us start with the today's class. And today's lecture is on introduction to the electrical networks and their types. So, the objective of this class is to discuss about um, electrical networks, to discuss about the various types of network elements, and to discuss about the various types of electrical networks. So, in our previous lectures, we have covered a brief introduction about the electricity and a little bit of physics that is involved in electrical engineering, specifically for basic electrical engineering. And we have also discussed about some of the circuit elements, active and passive elements. From this lecture onward, we would be starting the conventional data detail or material about the electrical networks. So let us start with the lecture. Now, what is an electrical network? As you can see, as in our previous lectures also, we have discussed a little bit about the electrical network. Now, from here onward, we would be discussing the electrical networks in detail. So, what do you understand by an electrical network? Before that, let us understand what is a network. Network is basically the interconnection. It is the interconnection of various, you can say, points or nodes or elements, right? So we all have network, we all have a friend network, we all have a social network wherein we are connected to one another through certain medium, right? So here we are not talking about the social network or the network of people. We are talking about the electrical network. In the similar manner, as we can say that an electrical network is also made up of certain elements. Okay, so when certain elements are connected to one another or are interconnected to one another in a certain topology. When I say topology, I actually mean to say that these elements can be connected in series with one another. These elements can be connected in parallel to one another. Or there may be a possibility that these networks may be connected to one another in series or parallel or series or parallel, like this. So each block here represents an element. So this element may be a resistor, it may be a capacitor, it may be an inductor. Means in general, we can say that an electrical network comprises of uh, circuit elements which are connected to one another in a certain way. We may have the series connection of all the elements, we may have parallel connection of all the elements, or we may also have a combination of series and parallel, right? Now when we talk about the circuit element, we actually mean to say uh, the elements which may be active and passive, both or both, active, passive, or both, right? We may have a network wherein we can have all the sources connected. We may have a network wherein we have all the passive elements connected, and we may have a network wherein we can have active elements as well as passive elements, as you can see in this diagram here, right? So now So I hope it is clear what is an electrical network. So I'll repeat, an electrical network is an interconnection of various electrical elements. And when we say electrical elements, we mean to say active elements and passive elements. And in active elements, as we have already discussed in our previous class, active elements are those elements which uh, generate the electricity, or these are also known as sources, means which provides electrical energy to the electrical system, and because of which the electrical system operates. Like your fan, it runs on electricity. Okay, so any other electrical appliance that runs on electricity, right? Now as you can see one term here, electrical circuit. So electrical circuit is nothing but it is also an electrical network. But there is a fine difference between electrical network and electrical circuit. There is a very fine difference. As you can see, there are two diagrams drawn, this one and this one. So this is, let us say, diagram 1 and this is diagram 2, for example. So in diagram 1, you can see there is one battery, and there is a resistors connected to one another, and all the circuit diagrams will have all the elements will have certain current flowing through them. You can see here, so there is an arrow shown, and you have uh, the current is flowing through all the branches, right, all the elements. But here in this particular circuit, if you see, one of the path is open, one of the path is open, right? So one of the path is open. Now in this particular path, there is no current. So I is equal to 0 here. So what is the difference between these two circuit diagrams? In this circuit diagram, you have all the paths, all the branches closed, and all the elements have certain amount of current flowing through it. But in this diagram number 2, one of the branch, one of the element does not have any current because it is open. So the fine difference is that we can say that an electrical circuit is that electrical network which has all the paths closed, which has current flowing through all the elements connected in it. So all the electrical circuits are electrical networks, and if we have one such electrical network where we have any of the path open, or if any of the element is not having current flowing through it, so we can term it as electrical network. But the general term which is used for these circuits is electrical network only. So both are electrical network, but since it is closed, the diagram one is closed in all respects, so we are calling it as electrical circuit. So okay, you must have heard about circuit, the word circuit, like the the track basically wherein we have Formula One races, right? It is a closed path, so that is why it is a circuit. Okay, so electrical circuit is that a loop or path wherein the current is flowing. Okay, fine. So let us go to the next slide. Now, as we already discussed these elements in our previous lecture, electrical network is, because now today we are discussing the electrical networks in detail. So that is why we would try to cover the elements once again uh, in detail, right? Now, active elements, because your electrical network comprises of two categories of element, two categories of circuit elements. One of the categories is known as active elements, and the another category of elements is known as passive elements. Okay, passive elements and active elements, right? Now, what are active elements? So active elements are those elements, as we have already discussed, active elements are those elements which deliver power to the other elements. In very general statement, we can say that active elements are those elements, active elements are also known as electrical energy sources. So these run the circuits. That means the elements which are responsible for the operation, functioning of electrical systems, of electrical networks are known as active elements. For example, your voltage source, current source, right? So what are voltage source, what are current source, that also we will discuss in detail, right? So as of now, we will understand that what is an active element. So active elements are those which deliver electrical energy to the electrical circuit, electrical systems, right? Then we have passive elements. So the passive elements are those elements, for example, resistor, inductors, and capacitor, which cannot deliver the power to the other elements, but they can absorb the power. Either they dissipate power like a resistor in form of heat, or they store the power in form of some energy. It may be in terms of charges as done by capacitor, or it may be in terms of magnetic energy as done by inductor, right? Now if you see, as it is mentioned here, in case of active elements, that active elements sometimes can absorb the power like passive elements. Now what does it mean? Absorbing power means that your element is dissipating the electrical energy, or it is utilizing the electrical energy for its functioning. being the source बीइंग दी सोर्स एलिमेंट होते हुए भी वो इलेक्ट्रिकल एनर्जी को यूज कर रहा है. इसका सबसे अच्छा जो एग्जांपल है वो क्या हो सकता है? इन्वर्टर बैटरी. देखिए, वी ऑल हैव, ऑलमोस्ट ऑल ऑफ अस हैव inverter battery system installed at our house. Now what happens when you do not have electricity? Means what will happen? This battery through this inverter will supply the electricity to the loads. Now what is load? Load is, for example, the fan, the television, or any other electrical appliance which is functioning on that electricity, right? Now when you don't have electricity at home, so at that time battery is operating as a source. It is through inverter supplying the electricity. But what happens when you have the mains back? So what will happen at that point of time? The mains take over the battery, and battery now will start getting charged. Now the same thing, battery which was acting as a source is now acting as a load. So that means now it is absorbing the power. It is not delivering the power. When it is not delivering the power, when you have mains and your battery is getting charged, right? The same is the case with your mobile phone also. When you are using your mobile phone or your laptop without adapter, so at that time your battery is acting as a source. It is running your laptop, your mobile phone. But when you charge your mobile phone, what happened? The same battery which was acting as a source for mobile phone is now acting as a load. It is absorbing the power, right? So that is the meaning of this particular line, this one. Okay, so the best example is inverter battery system, right? Now let us proceed further. uh, Now apart from these active elements and passive elements, these circuit elements are further categorized in three other categories. Like we have linear and non-linear elements, we also have bilateral and unilateral elements, we also have lumped and distributed elements. Now let us discuss them one by one. First of all, let us come to the linear and non-linear elements. Now we all have studied the theory of linearity in mathematics, uh, which all systems we call as the linear systems, right? We all know that any system which obeys the principle of superposition, principle of homogeneity, or superposition or additivity. So all such elements, all such systems are under the category of linear systems or linear elements. In a very simple statement, if we say that any element which shows a linear behavior between voltage and current, like V is equal to IR, right? So this is the Ohm's law. In case of resistance, if you see, so if you plot a graph here, you will get a line. So wherein the behavior between voltage and current across any element is linear. So such elements are linear elements. Another way of understanding linear elements is that any linear element, and of course the network also, that we will cover later on also in detail, which satisfy the principle of superposition, or we can say principle of homogeneity and additivity. So such elements, they come under the category of linear elements, right? Similarly, the non-linear elements are those wherein we do not have a linear behavior between the voltage and current. Okay, in such systems, what do we have? We may have a relationship wherein the graph, if drawn, if we draw, अगर हम वो ग्राफ ड्रॉ करते हैं वोल्टेज और करंट के बीच में, so वो that would come a non-linear type, like ये or something like this. So there would be a non-linear behavior between the voltage and current. So वो सब elements जिनमें behavior non-linear होगा, वो सब elements जो हैं वो किस category में आएंगे? Non-linear elements की category में आएंगे, right? So we have the sources and all that. Okay, so they come under the category of non-linear elements, right? Now let us proceed further. Now we can also say, because what we are saying that any such elements which obeys the principle of superposition is a linear element. So vice versa is also true, that any such element which does not satisfy the above principle, means superposition or homogeneity or additivity, if any element does not satisfy these principles, so that element is termed as non-linear element, right? So let us go further to the next slide. Now then we have bilateral and unilateral element. Guys, uh, for example, there is a resistance. There is a resistance which has a value R. Now if some current flows through this resistance, and let us say this current is I, so what will be the voltage? If you measure a voltage across these two terminals, what will be the value of voltage? It will be V is equal to I R. This will be the voltage drop, right? What will be the power dissipated across this resistance? The power will be PR is equal to I square R, right? This would be the power dissipated across this resistance. Now, for example, if the same resistance is taken and the current reverses its direction, अगर हम वही रेजिस्टेंस लेते हैं और उसके थ्रू करंट की डायरेक्शन को रिवर्स कर देते हैं, तो आप मुझे बताइए कि इसके अक्रॉस कितना वोल्टेज आएगा? V इज इक्वल टू आई आर, यही वोल्टेज आएगा. What will be the power dissipated? PR is equal to I square R. So that means in these two cases, if you have observed it very closely, in these two cases, but in the first case, the direction of current is from one, let us say point A to B, and in second case, the direction of current is from B to A. But when you talk about the voltage drop across the resistance, when you talk about the power dissipated by the resistance, in both cases it is same. In both cases it is same. That means by reversing the direction of current, इससे क्या साबित हुआ कि अगर आप करंट की डायरेक्शन को रिवर्स कर भी देते हैं, तो उस कंडीशन में आपके एलिमेंट के अक्रॉस, उस कंडीशन में आपके एलिमेंट के अक्रॉस जो एनालिसिस है, जो बिहेवियर है, जो रिस्पॉन्स है, वो चेंज नहीं हुआ. That means in both cases the voltage drop across that resistance is I into R, and the power dissipated is I square R. Okay, so that means there is no change in the behavior, there is no change in the response of the element when the direction of current reverses across, reverses through it. जब उसके थ्रू करंट की डायरेक्शन रिवर्स करती है, तो उस एलिमेंट के बिहेवियर में कोई बदलाव नहीं आता. So such type of elements we call as bilateral elements, right? As we can see, voltage current relationship is same for current flowing in either direction. That means whatever is the direction of the current through element, that will not affect the response of the element, right? So for example, you have resistor, inductor, capacitor, all they come under the category of bilateral elements. Now let us take a second case, guys. Let us take a second case. For example, you have a battery, and the positive and negative terminals are there. And for example, you have a diode connected, and then you have a resistance which is acting as a load resistance. So the value of this resistance is R, and this is a diode, and this is a voltage battery VDC, for example. Now guys, tell me, if the current flows through this particular circuit. Now you can see this is P type semiconductor, this is N type semiconductor diode, and we know the P type is connected to positive terminal of the battery. So this diode is, we will say diode is forward biased. I hope you must have studied this in your physics, a little bit about diode, right? If not, then no need to worry. This is just an example. Okay, so when a diode, the P-type side of diode is connected to positive terminal of the battery, it is always, as you is said to be forward biased. Now what will happen, because it is forward bias, what will happen, the current, this will behave as a short path ideally. ये कैसे बिहेव करेगा, शॉर्ट पाथ की तरह बिहेव करेगा, राइट? शॉर्ट पाथ मतलब जो फुल करंट फ्लो करवाता है अपने थ्रू. तो अब क्या हुआ, अब देख सकते हैं यहाँ से करंट फ्लो करेगा और रेजिस्टेंस जो है वो डिसिपेट करेगा पावर को. अब मान लीजिए सेम केस हम लेते हैं, सेम केस लेते हैं, ठीक है. अब सेम केस में हम क्या करेंगे, अब हम जो है बैटरी की डायरेक्शन को रिवर्स कर देते हैं. अब हम बैटरी की डायरेक्शन को क्या कर देते हैं, रिवर्स, minus positive, and the diode is connected here, right? And then you have a resistance connected here, right? And diode and a VDC. Okay, now because this P type is now connected to the negative terminal of the battery, so hence this diode is reverse bias. It is reverse bias, right guys? Now when diode is reverse biased, it behaves as an open path. So it behaves as an open path, negative and positive, and it behaves as an open path, right? Now when it behaves as an open path, so because the circuit is now open, so no current will flow through it, no current will flow through it, and hence the power, the voltage across this resistance, what will be the value of voltage across, it would be zero. Why it will be zero? Because it doesn't have any current. What is the power dissipated here? It is also zero, because the power dissipated now, PR is equal to zero, VR is equal to also zero, because now no, you don't have any current flowing through this circuit diagram. Now I hope you are clear what I want to convey to you. I want to convey that when we have changed the direction of battery, it has changed the direction of current also. But by changing the direction of battery or current, what has happened? The response of the circuit has changed. The response of the element has changed. The response of the element has changed. Such elements we call as unilateral elements. Such elements we call as unilateral elements, right? Okay, so they will have a different relationship, different behavior between voltage and current when the direction of either voltage or current is changed. जब हम voltage या current की direction को अगर change कर दें, तो जो elements में voltage और current का behavior भी change हो जाए, response भी change हो जाए, तो ऐसे elements को हम क्या बोलेंगे, unilateral elements, right guys? So the examples are vacuum diodes, silicon diodes, metal rectifiers, etc. Right? Let us come to the next category, lumped and distributed networks. Guys, I hope you are clear about the electrical circuit. As mentioned earlier, any electrical circuit is a combination of various elements, which may include active elements and passive elements. So let us see. I have drawn a circuit here, which has a voltage, DC voltage, a plus and minus, and has a resistance whose value is R1, and then one more resistance whose value is R2. All these elements are connected in series with one another. This is an electrical network, and this is also an electrical circuit, because the current will flow here, right? All paths are closed. The path is closed, right? Now, Here in this particular network, you can separate this resistance, you can separate this voltage source from one another. You can separate all these elements. These elements are physically separable, right? So any such element which can be separated from the network is termed as lumped element. It is termed as lumped element. For example, your capacitor, resistor, inductor, transformers, etc. Now just assume another case uh, wherein you have, let us assume one more case in which uh, sorry guys, sorry. So let us assume one more case, the case of transmission lines. The case of a transmission line. We have a powerhouse. Let us say a thermal power plant, and from here you generate electricity. You step up this electricity by using a transformer. Then you transmit this electricity to a distance transmission. Then you take down this electricity and step down it. Okay, then you distribute it, okay, to domestic. So you distribute it at your house or industry or wherever. So at your house you get the electricity, right? So here it is distribution point, means the electricity is being distributed. Now this whole scenario, if you understand the concept of a little bit about the transmission and resistance, we all know that a resistance, the formula for resistance is R is equal to rho L by A. What is rho? Rho is the resistivity of the material, right? For example, we may have a wire of copper, we may have a wire of aluminum, we may have a wire of iron, something like that. So they will have a different resistivity based on the material, right? Then this L is the length of the conductor. Okay, so L is, I'll write here, L is the length of the conductor, right? And then A is the area of cross section, right? So now just assume these transmission lines, they are also made up of certain material. They have length, they have area of cross section, and they are made up of certain material. So they have resistivity also, right? So that means they have a resistance, but you cannot see a resistance here. That means you cannot separate this resistance. You cannot separate this resistance. Okay. So because now you cannot separate this resistance, so it is physically difficult or impossible to separate. So such elements which cannot be separated are the distributed elements, right? There is one another way of understanding this uh, concept. There is one more way to understand this concept, and that is uh, by comparing the size of element with the wavelength of the signal that is being fed. एक और तरीका है इसको समझने का, वो ये है कि आप एलिमेंट के साइज को आप कंपेयर करें किससे, वेवलेंथ से. कौन सा वेवलेंथ? जो उस एलिमेंट को आप फीड कर रहे हो, दे रहे हो, उस सिग्नल का, जो सिग्नल आप उस एलिमेंट को फीड कर रहे हो. मान लीजिए आप एक रेजिस्टेंस को एक एसी सिग्नल के साथ कनेक्ट कर देते हो जिसका फ्रीक्वेंसी है 50 हर्ट्ज, राइट? नाउ you can have lambda is equal to c by frequency, right? So you can find out the wavelength, where c is the speed of light, f is the frequency. So when you compare the wavelength with the size of a resistor, so what would be the size of a resistor? You all have seen a resistor, it is very small. When you compare this wavelength with the size of a resistor, so this resistor is incomparable. incomparable. You cannot compare the size of a resistor with the wavelength of the 50 hertz signal given to this resistance. So when you, so we can say that the size of resistor is very 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 small as compared to the wavelength of the applied signal, right? So such elements are known as lumped elements, right? And when you can compare the size of the circuit element, for example a resistor, with the wavelength of the input signal, so such elements are known as distributed elements. For example, in case of transmission line, so you have a generator or powerhouse, then you have a step up transformer, then you have a transmission. So we all know that electricity is being transmitted to hundreds of kilometers, thousands of kilometers, right? So suppose there is a line, then you have a step down, then you have a distribution at your home. Okay, now this may be of thousands of kilometers. For example, the electricity is being generated at Tihri Dam and it is being distributed to Delhi. So we all know that the distance between Tihri and Delhi is more than 400, 500 kilometers, 400 kilometers. So this 400 kilometer is comparable to the wavelength of a 50 hertz signal, because we get 50 hertz AC supply at our home, right? So such elements wherein you can compare the size with the wavelength. If you can compare the size of element with the wavelength of the input signal, so you can term that element as distributed element. So I hope it is clear to you. So there are two ways of understanding this. One way is to uh, see it through the fact whether you can separate the element or not. If the element is physically separable, it is a lumped element. Or if the size of element is very very small as compared to the wavelength of input signal, so it is a lumped element. If the circuit element is not physically separable, so it is a distributed element. Or if the size of the circuit element is comparable with the wavelength of the input signal, we can say it is distributed elements. Okay, so there are two ways to understand this, right guys? Let us come to the next slide. Now let us come to the types of electrical network. Now based on the type of circuit elements connected to one another and forming an electrical network, we can categorize the electrical network. हमारे जो सर्किट एलिमेंट्स हैं जो हमने अभी पढ़े, एक्टिव एलिमेंट है, पैसिव एलिमेंट है। एक्टिव एलिमेंट क्या होता है? जो एनर्जी देता है। पैसिव एलिमेंट क्या होता है? जो एनर्जी, इलेक्ट्रिकल एनर्जी को, पावर को एब्जॉर्ब करता है, डिसिपेट करता है या फिर स्टोर करता है, राइट? फिर हमने देखा लीनियर एलिमेंट, नॉन लीनियर एलिमेंट, वो एलिमेंट जो सुपरपोजिशन प्रिंसिपल को, होमोजेनिटी प्रिंसिपल को, एडिटिविटी प्रिंसिपल को फॉलो करते हैं, ओबे करते हैं, वो लीनियर एलिमेंट्स होते हैं। जो नहीं करते हैं वो नॉन लीनियर एलिमेंट्स होते हैं। फिर हमने देखा बाइलेटरल, यूनिलेटरल। बाइलेटरल एलिमेंट्स वो होते हैं जिनमें आपका जो करंट की डायरेक्शन या वोल्टेज की डायरेक्शन अगर रिवर्स हो भी जाए तो उस एलिमेंट के बिहेवियर पे कोई फर्क नहीं पड़ता, वो वैसे ही बिहेव करता है जैसे करता है। लेकिन अगर करंट या वोल्टेज की डायरेक्शन बदलने से, चेंज करने से एलिमेंट के बिहेवियर पे, वोल्टेज और करंट रिलेशनशिप में असर पड़े, फर्क आए, डिफरेंस आए, तो ऐसे एलिमेंट को हम यूनिलेटरल एलिमेंट बोलते हैं। फिर हमने देखा लंप्ड एलिमेंट क्या होता है, डिस्ट्रीब्यूटेड एलिमेंट क्या होता है, ठीक है? बिकॉज ऑल दीज एलिमेंट्स आर रिस्पॉन्सिबल फॉर द ओवरऑल रिस्पॉन्स ऑफ द सर्किटरी। आपका इलेक्ट्रिकल सर्किट जो है वो क्या है? वो बना हुआ है इन सब एलिमेंट्स के द्वारा। ये सभी एलिमेंट्स कनेक्टेड हैं एक दूसरे के साथ, ठीक है? इनका अपना अपना एक बिहेवियर है, अपना अपना एक रिस्पॉन्स है। तो आपका जो इलेक्ट्रिकल सर्किट है उसका भी एक ओवरऑल रिस्पॉन्स होता है। उसी के बेसिस पे हम इलेक्ट्रिकल नेटवर्क्स को भी कैटेगराइज करते हैं। तो उस कैटेगरी में वी हैव लीनियर नेटवर्क एंड नॉन लीनियर नेटवर्क, देन वी हैव बाइलेटरल नेटवर्क एंड यूनिलेटरल नेटवर्क. Similarly, we have active networks and passive network. Then we have lumped network and distributed network. If you are clear about the elements, linear elements, non-linear elements, bilateral, unilateral, active, passive, lumped, distributed, so it would be easy for you to understand the networks also, right? So let us come to the linear and non-linear network. As I told you earlier also, that if any system possesses a linear relationship between the voltage and current, or if any system obeys the law of superposition, law of superposition, such systems, such electrical networks, they are under the category of linear networks, right? And if any system wherein there is no linear relationship between the voltage and current or any other parameters, so such network is under the category of non linear networks. वो नेटवर्क नॉन लीनियर नेटवर्क की कैटेगरी में आएगा जहां ओम्स लॉ ओबे नहीं होता, जो ओम्स लॉ फॉलो नहीं करते हैं, वो नॉन लीनियर नेटवर्क की कैटेगरी में आएंगे. ओम्स लॉ जहां फॉलो करते हैं, सुपरपोजिशन जहां फॉलो करते हैं, एडिटिविटी प्रिंसिपल या होमोजेनिटी प्रिंसिपल जहां फॉलो करते हैं, वो सब लीनियर नेटवर्क की कैटेगरी में आएंगे. इसको आप डायग्राम से भी समझ सकते हैं, जैसा कि यू कैन सी देयर आर टू डायग्राम्स हियर, द कैरेक्टरिस्टिक्स ड्रॉन बिटवीन करंट एंड वोल्टेज, right? So here you can see there is a linear relationship between. So here you have V is equal to IR relationship, right? Okay, so the slope of this line will be R, resistance. Okay, now and similarly you can see a graph here. So this graph is represent diode characteristics. It represents diode characteristics, right? So VI characteristics of diode, right? Now in this first diagram, this is, let us say, first diagram, this is second diagram. So in first diagram you can see the relationship between current and voltage is linear. So this is a linear network, means to whatever network these characteristics belong is a linear network. जिस भी network है characteristic है वो एक linear network है. यहाँ पे diode characteristics है, आप देख सकते हैं. ये जो ग्राफ है ये non linear behavior है. So it is a non-linear behavior. Because it is a non-linear behavior, so we call such network as a non-linear network, right? Now let us come to the next slide. So let us come to the bilateral and unilateral networks. As we discussed earlier also, in case of bilateral and unilateral elements, the same goes for the networks also. Like there are two networks, network 1, network 2. Now here we are using an AC supply. This is the symbol, guys, for there are two types of symbols for voltage source that we will also discuss in forthcoming lectures when we will discuss about the electrical energy sources. जब हम electrical energy sources को डिटेल में डिस्कस करेंगे तो तब हम वोल्टेज सोर्स, करंट सोर्स, उनका जो सिंबल है, रिप्रेजेंटेशन है, वो सब हम डिटेल में डिस्कस करेंगे. तो ये जो सिंबल है ये एक डीसी वोल्टेज सोर्स का सिंबल है और ये जो सिंबल है ये एक एसी वोल्टेज सोर्स का सिंबल. आप यहाँ देख सकते हैं साइन वेव है, बाई डायरेक्शनल सिग्नल को रिप्रेजेंट करता है. नाउ व्हाट विल हैपन, जब पॉजिटिव हाफ साइकिल होगा, जब पॉजिटिव हाफ साइकिल होगा यहाँ पे ये पॉजिटिव हो जाएगा, ये नेगेटिव हो जाएगा. करंट का डायरेक्शन क्या होगा, ये, राइट? ये लोड के अक्रॉस जब आप वोल्टेज मेजर करेंगे बच्चों, जब आप यहाँ पे वोल्ट मीटर लगाएंगे और वोल्टेज मेजर करेंगे तो वो वोल्टेज देगा V इज इक्वल टू IR. जब नेगेटिव हाफ साइकिल आएगा, अभी देखिए, जब नेगेटिव हाफ साइकिल आया तो नेगेटिव हाफ साइकिल में क्या हो बच्चों, ऊपर वाला जो एंड है वो नेगेटिव हो जाएगा, नीचे वाला पॉजिटिव हो जाएगा. तो करंट का डायरेक्शन रिवर्स कर दिया, यस और नो? तो करंट का डायरेक्शन जब रिवर्स किया तो क्या हुआ, आपके पास जब वोल्ट मीटर आपने लगाया उसने वोल्टेज कितनी मेजर की होगी, सेम V इज इक्वल टू IR आएगा. ठीक है, या इसका RL लगा लेते हैं, इसका लोड रेजिस्टेंस RL है क्योंकि R ऑलरेडी यहाँ पे दिया हुआ है तो इसको हम RL मान लेते हैं. ठीक है, अब दोनों केसेस में इफ यू have clearly observed this phenomena, in both the cases when the direction of current has reversed, right, there is no effect on the voltage being measured by this particular device, voltmeter. It will measure the same voltage. That means this load will have same voltage drop across itself. यानी इस लोड के अक्रॉस सेम वोल्टेज ड्रॉप आएगा, राइट? तो कोई फर्क नहीं पड़ा ना। अब चलते हैं अगले एग्जाम्पल पे, अगले नेटवर्क पे, ठीक है। अगला नेटवर्क क्या दिखाता है, देखिए अगले नेटवर्क में एक डायोड लगा हुआ है, राइट, एक डायोड लगा हुआ है। सो व्हाट विल हैपन when the positive half cycle will appear, so this end will become positive, this end will become negative, diode will be forward biased and the current will flow in this direction. If you connect a voltmeter here, so this voltmeter will give you a voltage V is equal to IRL. Now if the same circuit diagram, if the same circuit diagram is used, if the same circuit diagram is used, so I'll draw it here so that you don't have any confusion. So let us draw it here. We have a diode connected, we have a load resistance or load connected. So this is a load, right? Now this is a diode. Now for negative half cycle, this end will become negative, this end will become positive. So that means this diode will now be reverse biased. This diode now be reverse biased. Now what will happen if this diode is reverse biased? So what will happen, this point will behave as an open path. ये ओपन बन जाए, क्योंकि जब आपका डायोड रिवर्स बायस होता है तो वो इनफाइनाइट रेजिस्टेंस ऑफर करता है आइडियली करंट को। इनफाइनाइट रेजिस्टेंस मतलब ओपन पाथ, ठीक है। तो अब इस केस में देखिए तो ओपन हो गया, इसका मतलब है कि अब जो करंट था आई वो जीरो हो गया, इसका मतलब इस लोड से कोई करंट नहीं जाएगा। तो जब आप यहाँ पे वोल्ट मीटर लगाओगे और वोल्टेज मेजर करोगे लोड के अक्रॉस, तो वो ऑलमोस्ट जीरो वोल्टेज आपको दिखाएगा। तो मतलब कहने का ये है बच्चों कि जब आपने करंट की डायरेक्शन चेंज की, पहले केस में देखिए क्या हुआ, आपने करंट की डायरेक्शन और वोल्टेज की डायरेक्शन अगर चेंज की, इस लोड के अक्रॉस या इस रेजिस्टेंस के अक्रॉस वोल्टेज या पावर डिसिपेशन में कोई फर्क नहीं आएगा, उसके रिस्पॉन्स में, उसके बिहेवियर में कोई अंतर नहीं आएगा, कोई डिफरेंस नहीं आएगा। देयर विल नॉट बी एनी डिफरेंस इन द बिहेवियर, इन द रिस्पॉन्स ऑफ दिस पर्टिकुलर सर्किट, irrespective of the fact that you have changed the direction of voltage, you have changed the direction of current, the response of the behavior of the circuit will not change. Such networks are known as bilateral networks. Okay, such networks are known as bilateral networks. And in the second case, you can see while by changing the direction of current and voltage, the response of the circuit has changed. So we can say that it is a unilateral network, right? As it is mentioned also, a circuit whose characteristics, behavior is same irrespective of the direction of current through various elements, it is called as bilateral network. Resistance are the good example of that. Similarly, a circuit whose operation behavior is dependent on the direction of current through various elements is known as unilateral elements. For example, diodes, right? Okay, let us go to the next slide. So let us see the active and passive networks. Generally, all the networks which have a battery or a generator or a cell or an alternator, means any EMF source, any EMF source connected in it comes under the category of active network, right? कोई भी ऐसा नेटवर्क जिसमें एक EMF सोर्स लगा हुआ है, एक बैटरी सेल लगा हुआ है, तो वो नेटवर्क एक्टिव नेटवर्क की कैटेगरी में आता है। और ऐसा कोई नेटवर्क जिसमें आपका बैटरी ईएमएफ सोर्स नहीं लगा, तो वो सब जो है वो पैसिव नेटवर्क की कैटेगरी में आते हैं, राइट? दे ऑल आर अंडर द कैटेगरी ऑफ पैसिव नेटवर्क। लाइक एज यू कैन सी देयर आर डायग्राम्स शोन हियर, like these two diagrams belong to the active network example because you have a battery connected here, right? And then you have these two diagrams here wherein you don't have any battery connected. Because you don't have any battery connected, battery is an active element, right? So you don't have a, so these circuits are known as passive circuits or passive networks, right? Now let us come to the next slide, lumped and distributed. So again, the same definition you can take use for the lumped and distributed network also. A network in which all the network elements. Now, what are the network elements? What are the network elements? The resistor, capacitor, right? Inductor, transformer, etc. If the elements are physically separable, they are known as lumped network. All your small networks which you see, like your PCB and all that, they are basically lumped networks, right? Okay. Most of the electric networks are lumped network. They are lumped net because it is very easy to, or it is convenient to separate the circuit elements from there. Okay. For example, if you have a PCB wherein some resistors, capacitors, transistors, diodes are connected. Okay, and if some diode or transistor malfunctions, so it is very easy for you to remove that element from there and solder a new element there, right? So you can separate it. So it is a lumped network, right? But if in any network it is very difficult or it is very impossible, you cannot physically separate the elements like resistance, inductance, so it is a distributed network. For example, your transmission systems, a generation point is there, then transmission is there, then distribution is there. We all know that the transmission lines, they are made up of some material like aluminum, for example. So aluminum has resistivity, aluminum, so these lines have a length basically L. These wires will have area of cross section, so they will have R is equal to rho L by A resistance. But you cannot separate resistance out of here. You don't have a resistor connected here. They possess resistance. That's the inherent characteristic of a conductor. ठीक है, रेजिस्टेंस किसी भी कंडक्टर की इनहेरेंट कैरेक्टरिस्टिक्स होती है, पर आप कंडक्टर से रेजिस्टेंस नहीं निकाल सकते अलग. आप रेजिस्टर को एक सर्किट डायग्राम से अलग कर सकते हो, लेकिन एक कंडक्टर से, एक वायर से रेजिस्टेंस बाहर नहीं निकाल सकते, right? So it is not physically separable. So all such things come under the category of distributed network. So like there are two circuit diagram, this one and this one. In this you have an inductor connected, resistor connected, capacitor connected, a voltage source connected, so you can separate them. But here in this transmission line you cannot separate any inductor, capacitor or like that. Okay, so now, so guys, this was all about today's lecture, today's class. We have discussed about the electrical network. What is an electrical network? What is an electrical circuit? What are the various types of circuit elements? Categories basically. What are the various categories of circuit elements, right? Then we have seen what are the various types of electrical networks, right? So this was all about today's lecture, today's class. Thank you so much, dear students.